Welcome to this seminar on a very important topic, statistical power. This is a topic that's not usually taught in basic courses. That's probably why you're have signed into this seminar. It's usually considered too difficult, and it is a difficult topic, but it's still it's important. Some statisticians, I know a friend of mine, several years ago, told me he considered it the most important concept. That was his words, the most important concept. Now, I don't know if I agree that it's the most important concept, but it is very important. If you want to present your data in a convincing way in reports and regulatory submissions. Now, it's a difficult topic. What we're going to have to do first, in order to explain power, we're going to have to explain or review what a test of significance is. We'll use a t-test as an example, and based on that information, then we'll be able to explain what power is. First off, a little vocabulary, not too much, just the word, a couple words. Statistic. What does the word statistic mean? It refers to some kind of summary value, like an average or a range or a median or a standard deviation or something. It's some kind of summary value from data in a sample. So not the entire population, but just you take a sample, and if you take the sample average, a sample range, a sample standard deviation, or whatever, each one of those numbers is called a statistic. Now, you hope that that statistic is close to the population value for average or range or whatever. Now, the population version of it is called a parameter. So the population average is a parameter. The population standard deviation is a parameter. So statistic and parameter. Now, the science of statistics takes these and accurately, using mathematics, estimates or calculates what these are. That's the purpose. The purpose of taking our statistic is not to find out what the average of the sample is. Our purpose is to use that average of the sample to estimate what the population average is. Typically, this is done using, at least one of the ways this kind of thing is done, is to use confidence intervals. So whenever you have a sample average, a sample mean, you're wondering, well, where is the true answer? Where is the parameter? We don't really care about the sample. What we care about is the population, the parameter. Where is the parameter mean? Well, it's somewhere in the confidence interval. So we draw a confidence interval on either side of the mean and the upper and lower limits. This is the upper limit. This is the lower limit of the confidence interval. And you might, how confident can we be? Well, it depends upon how it was calculated. You can put a confidence value into the formulas. And for example, if we had put into the formula a 90% value, then this would be a 90% confidence interval. If we wanted to be more sure of where the parameter was, then we could have a 95% confidence interval. Okay, and you can see that it gets bigger the more confidence you want, and 99. Now, it may be obvious to you, but somebody may come up and say, well, they want to be 100% confident. And I'm hoping you have already guessed the fact that the answer to such a question would be minus infinity to plus infinity. So anytime you have confidence intervals, there is well, first, every time you have a sample, there's some uncertainty. And to use this sample to estimate the parameter, we're going to have to quantitate that uncertainty in terms of a confidence. And that's so we talk about percent confidence intervals. So this is part of the formulas.